So here we have to explain the concept of the monotonic function, and we shall define local maxima, local minima, and the critical points and the point of inflection. So what is meant by a monotonic function? So by a monotonic function f in an interval I, we mean that f is either increasing in the interval I or decreasing in the interval I. So by a monotonic function, f in an interval I, we mean that function f is either increasing in I or decreasing in the interval I. So the rule is that every monotonic function has its maximum or minimum value at the endpoints of the domain of the function. Every monotonic function has its maximum value or its minimum value only at the endpoints of the domain, only at the endpoints of the domain of the function. And there is another rule that every continuous function on a closed interval has a maximum and a minimum value. Every continuous function on a closed interval, has a maximum value also and a minimum value also. So these are the two rules. You should know this. And so now we shall write the definitions of local maxima and local minima. So the rule is that let f be a real valued function. It means that x also should be real, and the function f of x should be also real. So let f be a real valued function, and let c belongs to the domain of the function f. C is a real number, which suppose it belongs to the domain of the function f. Then we can say that c, the point x equal to c, is called a point of local maxima. It's called a point of local maxima if there is an h greater than 0 such that f of c is greater than or equal to f of x for all x in c minus h to c plus h, where x does not belong to c. The value f of c is called, so it will be called as a local maxima if the function f of c is greater than or equal to f of x for all x in c minus h to c plus h, where h is a very small number greater than 0. So the value f of c is called the local maximum value of the function f. Then the point x equal to c will be called a point of local minima. Is called a point of local minima if there is an h greater than 0 such that the function f of c is less than or equal to f of x for all x in the interval c minus h to c plus h. Uh, and then the value f of c is called the local minimum value of the function f. And then the value f of c is called the local minimum value of the function f. Okay. So the value f of c is called the local minimum value of the function f. So then we shall tell one theorem, that is the theorem based on local maxima and local minima. So let f be a function defined on some interval I, and suppose there is a real number c which belongs to that closed interval I. So suppose c belongs to I, and if if the function f has a local maxima or local minima, the local maxima or local minima at x equal to c, then either the derivative of the function at x equal to c should be equal to 0, or f is not differentiable at c. Then either I can say either f dash c equal to 0, or the function f is not differentiable at c. Differentiable at x equal to c. um, and then so x equal to c will be called, so there is another rule that x equal to c will be called a critical point. X equal to c will be called a critical point of the function f if if either the derivative of the function at x equal to c, it means f dash c, that is equal to 0, or f is not differentiable at x equal to c. F is not differentiable at x equal to c. So then x equal to c will be called as a critical point of the function f. And then what is meant by the point of inflection? Mm. If f dash x does not change the sign, if f dash x does not change the sign as the value of x increases through c, increases through c. It means that if f dash x, or I can say if f dash x is not changing the sign, is not changing the sign, changing the sign of as x belongs to c minus h to c plus h for some h greater than 0, then we can say that it is a point of inflection. Then x equal to c, then we can say that x equal to c is neither a point of local maxima or local minima. X equal to c will be called, x equal to c will be called a point of inflection. X equal to c will be called a point of inflection. Inflection. Since why? Since at that, when f dash x is not changing sign for in some interval which contains the number c, uh, then x equal to c will be neither a, will be neither local maxima nor local minima. So then x will be neither local maxima nor local minima. So an example of point of inflection, an example we can say that suppose we have f of x equal to x cube. So the graph of f of x equal to x cube is somewhat like this. So this is y equals to x cube. And then at x equal to 0, so f dash x will be, it will be 3x square. So therefore f dash 0, that is 0 only. But if we take some value which is slightly less than 0, suppose f dash uh, minus 1 by 2 if we take, so that will be also greater than 0, and f dash 1 by 2 also if we take, that will also be greater than 0. So it means that the sign of the f dash x is not changing as x increases through 0. So as x belongs to 0 minus h to 0 plus h for some h greater than 0, it means we are taking some interval which contains the number 0. So in this interval, the f dash x is not changing the sign. F dash x is not changing the sign. So in the interval which contains 0, f dash x is not changing sign. Therefore, x equal to 0 will be called a point of inflection in this case. It will be called a point of inflection in this case. So And suppose if we have the function f of x equal to, suppose, x square plus 2, suppose, then the graph will be somewhat like this. So then we can see that at m- at the local minima, so here the local minima is x equal to 0. Since why? Since f dash x that is equal to 2x, so f dash 0 will become 0. The slope is 0, and f dash x is changing sign from negative to positive. Therefore, it is a local minima. And when the graph is suppose like this, it is suppose if you take the function y is equal to f of x equals to 3 minus x square. So this at point, so then f dash x will become minus 2x. So f dash 0 will become 0, and the slope f dash x will change from positive to negative. So this point will be the local maxima. So here in this case, the local maxima of this function will be x equal to 0. So simply the rule is that if f dash x changes the sign, f dash x changes the sign from positive to negative, then and f dash, so f dash x changes sign from positive to negative as x increases through c, as the value of x increases through c, and f dash c that is 0, means the slope of the function at x equal to c that is 0, then x equal to c will be a point of local maxima. So it is the first rule. And if the function, if f dash x changes the sign from negative to positive as the value of x increases through c, and also f dash x, f dash c that is 0, then x equal to c will be a point of local minima. X equal to c will be a point of local minima. And the third rule is that if f dash x does not change the sign, it means that it is going from negative to negative only, or it is like going from positive to positive only. It means that it is not changing the sign. Then as x increases through c, and f dash c that should be equal to 0, then we can say that x equal to c will be a point of inflection. Then x equal to c will be neither local maxima, nor local minima, and it will be called as a point of inflection. It will be a point of inflection. So for the first case, we can give an example of the function like this, which is suppose the function f of x equal to 3 minus x square, suppose. So here x equal to 0 is the point of local maxima. Since why? Here the slope is changing from positive to negative, and f dash 0, that is 0. It means the slope of the function at x equal to 0 will be 0 here. And for the second case, we can give an example, which is suppose x square plus 2, f of x equal to x square plus 2. So then here f dash 0, that is 0. It means f dash 0, that is 0. And when the function increases through, when x increases through 0, then the slope of the function also changes from negative to uh, positive. So the point x equal to 0 is the point of local minima here in this case. And for the third case, we can give an example, which is the function f of x equal to x cube. So its graph is like this. So at x equal to 0, the slope is 0 only. It means f dash 0, that is 0. And as x increases through 0, then the slope is remaining positive only. It means f dash x is greater than 0 always as x increases through 0 here in this case, as x increases through 0. Here we can see that when we take one value which is slightly less than 0, the slope is having means f of x is having a positive slope. And when we take some value which is slightly greater than 0, then at that x also the slope of the function is greater than 0 only, means it is having a positive slope. So the slope f dash x is not changing its sign, it is remaining positive only as x increases through 0. Therefore here in this case, f x equal to 0 is a point of inflection here. X equal to 0 is a point of inflection in this case. So hope you have understood the concept. And one example, suppose we take like f of x equals to mod x. So then the graph is somewhat like this. So here we can say that f dash 0 does not exist. F dash 0 does not exist. Since it means that the function f of x, it means that the function f of x is not differentiable, at x equal to 0. At x equal to 0. Since why here the left hand, on the left hand side, the slope is having slope is -1, and on when we take one value which is slightly greater than 0, then the slope is +1. So the left hand derivative is not equal to the right hand derivative at x equal to 0. It means that I can say that LF dash 0 is not equal to RF dash 0. It means the right hand derivative of the function at x equal to 0 is not equal to the is not equal to the right hand derivative of the function at x equal to 0. Hence, at x equal to 0, the function is not differentiable. Hence, we can say here, hence the x equal to 0 point is a critical point of this, is a critical point of the function, of this function. So we know that at the critical points only, these three things will come. Means at the critical points only, the local maxima can come, or the local minima also can come, or the point of inflection also can come. And critical point, how to find? Those points where f dash x is, f dash c is 0. If f dash c is equal to 0, then it is a critical point. And if f dash c does not exist, it means it means the function f of x is not differentiable at x equal to c, is not differentiable at x equal to c, then also it is called as a, then also x equal to c will be called as a critical point. So here we can see that the minimum value of the function comes at x equal to 0. Therefore, minimum value is f of 0 only. So therefore, x equal to 0 is a local minima of this function f of x, which is mod x. So if f dash c is equal, it means if the slope of the, suppose we take one function which is suppose like this. Suppose this is the y-axis and this is the x-axis, and we have a function whose graph is somewhat like this. So the points where there is a sharp edge, means where there is some kink, then at those points the slopes on either sides are not same. So at those points the function is not differentiable. So here, if we take this point as C3, this is C4, and this point is C2, and this is suppose C1, then all these 4 points are called the critical points. Since why at C1, at x equal to C1 and at x equal to C2, f dash x is equal to 0. It means f dash C1 that is equal to f dash C2 that is equal to 0. And the function f of x, suppose it is the graph of y equal to some function f of x, and the function f of x is not differentiable, also is not differentiable at x equal to C3 and C4. So all these points, which is C1, C2, C3, and C4, are the critical points of the function, are the critical points of the function. So about C1, we can say C1, the slope is increasing, means the slope is changing sign from positive to negative. Therefore, C1 is a point of local maxima here. And at point C3 also the slope is changing from positive to negative. So C3 is also a point of local maxima. But C2 and about C2, when x increases through C2, then we can see that the slope of the function, means f dash x, is changing the sign from negative to positive. And similarly about C4 also, when x increases through C4, then the slope of the function, which is f dash x, that is also changing the sign from negative to positive. So therefore C2 and C4 both are the points of local minima. So C2 and C4 are the points of local minima, and C2, C3, and C1 are local maxima. So hope you have understood the concepts of the critical points and how to find the local maxima, local minima, and the point of inflection of a function by using f dash x. Thank you.